Our objective for today, I can derive a quadratic equation of a parabola. I can derive a quadratic equation of a parabola. So what's our main concept for today? Parabolas. I'm going to like, you already showed us parabolas. Yeah, but today we're going to go more into details with them. So your home play for tonight is deriving the quadratic equation of a parabola 4 times, or at least 4 times, at least. They're like, what does that mean, Mr. Q? Whatever process I show you, you need to study it by writing it, rewriting it completely at least 4 times. So just copying it, Mr. Q? No, listen to what I'm saying. I'm going to show you the process. You're going to go home, you're going to paper, you're going to start writing it, you're going to get stuck, you're like, oh, let me look at my notes. Look at your notes, continue writing it, look at your notes again, continue writing it until you're done. Turn your paper over. You're going to rewrite it again without looking at your notes. You're going to get stuck maybe 3/4 of the way. Look at your notes, finish it off, turn the paper over, get another paper, do it again until you don't get stuck. Yes? All right. Parabola. What is the parabola? The set of all points equidistant from a line and a point. The line's called the directrix, and the point's called the focus. The set of all points equidistant from a line and a point. The line called the directrix, and the point called the focus. The set of all points equidistant from a line and a point. The line called the directrix, and the point called the focus. Copy that, and then I'll go over the definition. I'm gonna try and break this down as simple as A, B, C. And then we're going to add, and it's going to snowball really quick. So please focus. Here it goes. Writing utensils down, look up to the screen. So, a parabola. We know what it looks like, right? We've been sketching them, we've been graphing them. But according to the definition, let me explain what a parabola is. It says, the set of all points equidistant from a line and a point. The point called the focus, the line called directrix. So I'm going to sketch my focus. There it is. And I'm going to sketch my directrix. There it is. And you're just paying attention right now. So if I was to sketch a point that's equidistant between the focus and the directrix, I'm going to place a point midway between these two because that would be the same distance. Do you agree with that? Same distance from here to here, from here to there. So if I was to place another point, let's say about right there, that means this distance is the same as this distance. Do you agree with that? If I was to place another point about right there, this distance is the same as this distance, and you can actually see a little square here for me. Do you guys see it? Yeah. Any questions with that? So if I continue placing a bunch of little points, eventually, do you guys see half the parabola here? Can you picture it? Yes? That's all the definition says, that it's a bunch of little points equidistant from the line, which is the directrix, and the focus, which is that point. And at the end, we should end up with something like that. Is that clear enough for the definition? Yeah, right? Copy that, please. Make sure you put arrows at the end. All right. And for non-example, I'm going to just use a simple one. How about that? Is that a parabola? No, it's a straight line, yes. All right. Do a hashtag. I'm going to give you a hashtag so we can go a little bit more expeditiously through the lesson. Damn. See, I was a language arts teacher yesterday. So how about equidistant points? Yes, from what? From the directrix and the focus. So today, I'm going to have you guys derive a quadratic equation for a parabola, and it's going to end up looking like this. Underneath your prayer model, write this down. Standard form equation of a parabola, it should look like this at the end. Y equals ax squared. You're writing that down underneath your prayer model. Standard form equation of a parabola. Y equals ax squared. Or, what's another way of writing that? Ax squared equals y. All right? We got it? All right. So, at the end, we need to end up with something like that. Itty bitty that. But it's going to require an entire page. So, turn your paper over. And we're going to start way at the top. Way at the top. For those of you that write with your feet, get your pencils on your hands and write smaller, please. Decent small, not too small and not too big. All right? So that we can fit our work. All right? So, at the top, you're going to write deriving a quadratic equation of a parabola. Nice and legible like mine. And once again, you're using the blank sheet I gave you, and you're doing this in the back, right? You are going to need your color pens. Get those ready. And if you have a highlighter or whatever, also use that. Once again, I'm going to do like how I always do. I'm going to scaffold, do it tic-tac-toe so you guys can understand everything along the way. Here it goes. So, to get started, what would you think I would do? No. We need to get to the formula. What I'm saying, to graph a parabola, what shall I do? Yes. Make the shape. But how do we make the shape? According to the definition, what do we need? A point and a line. So that means I'm going to start with my red point about an inch from the top of your paper. Place a point, and we're going to call that the focus. An inch below that, I'm going to sketch a horizontal line in blue. And what do we call that one? Directrix. Directrix. All right. So here we go. First step, we need one point to get started, aside from the focus and the directrix. So where is the most obvious point of a parabola? Between what? The focus and the directrix. So halfway there, I want you to place a point. So to show that this is halfway, that means that this distance is halfway from here to here. So that means there should be a point on the directrix. I'm going to show you the point. Everybody understands that a line is made with a bunch of points, right? Yeah, so there's a point. And you're copying this down, right? Okay, good. All right. So, do you agree that this distance is the same as this distance? Yeah, so I'm going to label this one D1. That means this is our what? D2. Now, for some of you to kind of like center your attention as to where we are in space, I'm going to do this. I'm going to create a coordinate plane. So with black, I'm going to sketch a line going through the midpoint. Sketch a line going through the midpoint. There it is. And that line we're going to label X. So if that's x, what do we need? Everyone? A y. So the y is going to go through all 3 points. That's our y. Roberto, I don't see you copying anything. All right, there it is. Pretty good, yes? All right, I'm going to zoom in now. Here it goes. So we have our directrix, our x, our y, and 3 points. Let's label our points. This point. Tell your neighbor the coordinate for this point. 0, 0, that is correct, because that's the point of origin. It's where the x and the y intersect, yes? All right. So that means if I get a coordinate for the focus, I know that my x value is what? 0, because it's right on the y-axis. But for the value for y, I'm going to label it P for point, because that was the first point I started with. Okay, so now I'm going to go to this point on the directrix. What is our x value for that point, everyone? 0. Now, look at this one. What is the y value for that one? Negative P. That is correct. All right. Any questions up to right there? We're good? Okay, so this is what we're saying. That this distance is the same as this distance. So from this point to this point and this point to this point. So, but Mr. Q, what if I want to create a new point? Okay, so I'm going to switch to black again, and I'm going to place a new point. Where do you want the point? Here? About right there? Yeah, so I'm going to place it there. Don't place it yet. Let me show you something really quick. I place it there because I want you to see that this distance is the same as this distance visually. Do you guys see a square right here? So therefore, can you agree that this side is the same as this side? Yes. So place your point there, kind of like visualize it on your paper that it makes like a little square, that point. And this new point, I'm going to change it to blue, and I'm going to label it X, Y. All right. So what are we saying? That this distance from here to here is our new what? Our new D1, our first distance. So obviously from this point, there must be a point here, so that this distance is our what, everyone? D2. Mr. Q, so you're saying that this D2 is that one? No, no, no. What I'm saying is that the distance from here to this point and here to this point, our new point, this is D1 and this is D2. Are we there so far? So, now, do we really need more little points to kind of like sketch our little curve right there? No, so let's sketch our curve. Like so. That's half of it. And I'm only going to do half for right now because we know we can get the picture of doing the other, right? So if you look at the diagram we just created, what is the only thing we haven't labeled? The new point on the directrix. Do you guys notice that? All right, this point, we know that the y value is what? Negative P. You guys see that from here? And our x value, since this point is xy, so this should be what? X. That is correct. All right. So now we're there. Let me zoom out a little bit. A little bit. There it is. So now that we're here, we can conclude that if I go point by point on this curve right here, we can conclude that what? That distance 1 will always be equal to what? distance 2. Do you agree? From each of the points that we continue doing, from the focus to the parabola and from the parabola to the directrix. All right. So, Mr. Q, how is this going to help us come up with an equation? We already started it. Look at this. Didn't we start an equation here already? But we don't know what the distance of 1 is. Well, let's find out. On this side, I'm going to write distance of 1 and use my distance formula. What's my distance formula? Square root, parentheses, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Step 2, b sub 1 is square root, parentheses, minus squared plus parentheses minus squared. Roberto, you got that so far? Oh, okay, good. All right, so we're going to fill this in for D1. Now, for you to visualize it, I'm going to use my highlighter to show you my D1. D1 is right here. You guys see D1 there? D1 is in between 2 points. What points are there? 0P and XY. That is correct. 0P and XY. So what does that mean, Mr. Q? That I need to label this. This point in red, I'm going to label this as my X sub 1, Y sub 1. And in green, that means that this second point over here is my what? X sub 2, Y sub 2. Here it goes again. Between these 2 points, right, is D1. That means this first point is my X sub 1, Y sub 1. That means this second point is my X sub 2, Y sub 2. Let's substitute values in here. Here we go. I'm going to start with the X sub 1, Y sub 1. What is X sub 1? 0 goes there. What is Y sub 1? P, and it goes right there. All right. What is X sub 2? X sub 2 is X. Y sub 2 is Y. All right. Now that we have that, let's simplify. And I'm going to zoom in now. Here it goes. D sub 1 is equal to, this is 0, that leaves us with x, and we have a square, so that leaves us with what? X to the second power, plus. We're going to rewrite this as 2 factors, because that's what it says with a square. Is that correct? So we can expand it. Y minus P times Y minus P. All right. D sub 1 is equal to square root x squared plus, what is y times y? Y squared. What is y times negative p? Negative py. What is negative p times y? Negative py. And negative p times negative p, that's positive p squared. Let's simplify that. D sub 1 is equal to square root x squared plus y squared. And what is negative py, negative py? Negative 2py plus p squared. Can we simplify any more? No, there's nothing else to combine. So we're done with what? D1. Now we have to do, yes. Do the same thing to the other side. I'm going to go to this side where D2 is at. I'm going to write D sub 2 is equal to square root, your distance formula again, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. D sub 2 is square root, parentheses with a minus squared plus parentheses with a minus squared. So now we need our new 2 points. Let me show you the sketch. And I'm going to switch to a highlighter in pink. Where's my D2? Right here. Right there. So what are my 2 points? This one up here, which is xy, that's already labeled what? X sub 2. So what are we going to label this one down here? In red. This will be our what? X sub 1, y sub 1. That is correct. Because I'm looking at these 2 points that make this distance, yes? So, what is x sub 1, everyone? X. What is y sub 1? Negative p. Alright? In green, what is x sub 2? X sub 2 was x. What is y sub 2? That one was y. Alright, I'm going to zoom in. Now that we're there, let's simplify. We got d sub 2 is equal to square root. Let's see, what is x minus x? This cancels, okay. So we're going to rewrite this as 2 factors, yes? What do I write? y plus p, yes, because negative times a negative is a positive, times y plus p. D squared is equal to square root. What is y times y? Y squared. What is y times p? Py. What is p times y? Py. And what is p times p? P squared. Let's combine like terms. D sub 2 is equal to, Roberto, you got this? All right, good. Y sub 2 plus 2py plus p squared. Can we simplify any more? No. All right. All right, let's go back to our premise. What was our premise? Here he goes. We said that what? That d sub 1 is equal to d sub 2. Do we know what d sub 1 is now? Do we know what d sub 2 is now? Yes, so that means I'm going to place an equal sign here, and I'm going to write what d sub 1 is. D sub 1 is square root x squared plus y squared minus 2py plus p squared. And what is d sub 2? Square root y squared plus 2py plus p squared. All right, now all we have to do is solve for y. Simple. Let me zoom in. Do both sides have a square root? How do we cancel those square roots? Squared and squared. This cancels that. This cancels that. That leaves us with x squared plus y squared minus 2py plus p squared is equal to y squared plus 2py plus p squared. All right. Look up. Here it goes. So in order for me, look up, guys, if I wanted to cancel this p squared, what would I do? Minus p squared minus p squared. But what's going to do that to this side? Here goes again. If I wanted to cancel this one here, what do I need to do? Minus p squared minus p squared. What's going to happen to both of them? They're going to cancel. That's because they have the same value on both sides. So what do I need to do to make it simple? Just cancel out like terms from both sides. So what can I cancel? P squared, what else? 2py is not the same. This one has a minus and this one has a plus, so y squared and y squared. What do we have left? We have x squared plus, minus 2py equals to 2py. All right, let's get all like terms to one side. I'm going to do what? Add 2py, add 2py. That leaves us with x squared equals 4py. Now I need to leave y by itself. What is 4p doing? It's multiplying, so how do we get rid of it? Divide by 4p, divide by 4p. That leaves us with, let's see, let me move this up. That leaves us with y on this side And on this side I have, look up, I can leave it as x squared over 4p, but what is the coefficient here? 1, so I'm going to leave it as a fraction. 1 over 4p, and what's on the side? X squared. This is my standard form. Let's see if it looks like the one I gave you at the beginning. I said ax squared plus y, I'm sorry, x squared equals y is our standard form, isn't it? Does that look like that? Yes. Piece of cake? Yeah. Let's look at it from afar. Let's see. It makes a heart. Aww. You guys see it? Aww. No, never mind. You guys don't see it? Are you serious? Yeah, if I was to go like this. Aww, there it is. So that's how you derive the quadratic equation of a parabola. So you're saying, so what does that mean for the home plate, Mr. Q? That on a blank sheet of paper, you're going to get home, you're going to start doing the sketch. You're like, what if I don't remember? Well, I'm recording it, number one. Number two, you have the notes in color. Very good. Very good that everybody brought their colored pens. So you do it once. You're going to have to look at your notes to follow it along. You do it a second time. Try to do it without looking at your notes. Then you look when you do need to look. A third time, you're going to get almost through the whole thing. A fourth time should get you almost, if not all the way through, all the way through. But then here comes the fifth time just for extra practice because you guys love to practice. Because coming Monday, as you walk in, what if I give you a blank sheet of paper? The whole thing. Including the graph. Yeah, the graph is the one that helps you do the whole thing. Because filling in all this and just simplifying, that's the simple stuff. Is that correct? Setting it equal to each other and simplifying, that's the simple stuff. What is the harder part? This one. This is the challenging part. To remember this without any numbers. The only numbers we use were what? 0 and 0. Oh, and the sub 1 and sub 2. Okay? All right? So once again, your home plate is for those only. Make sure it comes out like a heart, maybe, hey, cue merch right there. Let's go. Anyways, I'm going to stop the video so we can continue on with an activity. Enjoy, guys. Make it a math family night. Bye.